Dear students, today we would like to discuss about probability theory. Probability theory is applicable in many engineering applications. Now let us see some important terminologies before learning the probability theory. The first term in the probability theory, what we should learn is sample space. Sample space can be defined as set of all possible outcomes of an experiment is known as sample space. For example, in tossing a coin, the sample space is head, tail. In rolling a die, the sample space is 1, 2, 3, 4, 5, 6. The next terminology is exhaustive events. The total number of possible outcomes of an experiment is known as exhaustive events. Should keep in mind that sample space is set of all possible outcomes. Exhaustive events is nothing but the total number of all possible outcomes of an experiment. What's meant by event? Event is a set of possible outcomes and it is a subset of sample space. Example for event: in tossing a coin, getting tail or head is an event. For example, for exhaustive events is in tossing a coin, exhaustive events are 2. In rolling a die, the exhaustive events are 6. In a pack of 52 cards, the exhaustive events are 52. Favorable events: the number of outcomes which favors the happening of an event are known as favorable events. Example, in rolling a die, the number of cases favorable to getting 2 is 1. In rolling of 2 dice, the number of cases favorable to getting some 3 is 2, that is 1, 2 and 2, 1. Mutually exclusive events: in rolling a die, or two possible, that is, if occurrence of one event prevents the occurring of other event, then the two events are said to be mutually exclusive events. In tossing a coin, occurring of head prevents the occurring of tail. So these two events are mutually exclusive events. In rolling a die, occurring of one prevents two events 2, 3, 4, 5, 6. So these events are also called as mutually exclusive events. Equally likely events: if one of the event cannot be expected to happen occurring of another, then these events are known as equally likely events. Example, unbiased coin and unbiased die. Unbiased coin is nothing but a normal coin. Biased coin is nothing but the shape of the coin may be some, for example, it can be a cone or rectangle. Unbiased coin, the shape is a circle. Independent events: two events are said to be independent events. The happening or failure of one event does not affect the happening or failure of another event. Example, In rolling of unbiased die, getting of 1 in the first throw is independent of getting of 1 in the second throw. The condition for independent events is P of A intersection B equal to P of A into P of B. In detail about this we will be seeing later. Dependent events. Two events are said to be dependent events if the happening or failure of one event will affect the happening or failure of another event. Example, drawing a card from a pack of cards and it is not replaced before drawing the second card. The result of the second draw is depending on the first draw. These are all the few terminologies in the probability theory. Based on these terms will be using while we are discussing some probability concepts. We can define the probability in three ways, three approaches of probability. The first approach is mathematical approach or classical approach or priori probability. According to this approach, the probability of event equal to favorable number of events divided by exhaustive number of events. The main limitation of this, if the total number of events are infinite, then the probability of any particular event will be 0. But that is not practically it is not correct. See here, exhaustive. If it is infinity, anything by infinity can be written as 0. If you take infinite number of samples, infinite number of elements or infinite number of balls, what is the probability of getting one ball? Surely we will be getting a one ball. The probability should be 1. But we are getting here 0 probability. So this approach fails when exhaustive events are infinite. So we will be going for second approach, statistical or empirical probability or a posterior approach or relative frequency approach. From this approach we will be applying the limit P of E equal to limit n tends to infinity m by n. This approach will not be giving an exact value. It's not a precise, because which requires large number of exhaustive events. So this second approach also fails. Second approach is valid only when exhaustive events are infinite. If they are finite, the second approach cannot be used. So to avoid these limitations, we will be going for axiomatic approach. We are having 3 axioms. That is, the first axiom is probability value always lies between 0 to 1. Second axiom is total probability value is 1. Third axiom is P of A1 union A2 union A3 union and so on equal to P of A1 plus P of A2 plus and so on, provided A1, A2, A3 are mutually exclusive events. These some words are the technical words. You should know the meaning of the technical words. At least mean you should take it as greater than or equal to. That is minimum. At most is less than or equal to. Maximum. Whenever we use a product, we should use an intersection. Addition means union. At least or either or means you should use it as addition. Simultaneously or one after the other means multiplication. If A or B means you need to use union. A and B means you need to use intersection. You should keep in mind that neither A nor B means you should use this formula. P of A bar intersection B bar equal to P of A union B whole bar equal to 1 minus P of A union B. Exactly 1 A or B. P of A del B equal to P of A bar intersection B plus P of A intersection B bar.